Okay. Yeah, I just sent one now because I wasn't sure if I got that out on Monday or if it just didn't go through or what. I couldn't remember and I couldn't find any record of it, so I went ahead and sent it out again just now. Fluid lab? Yeah. Okay. Well, now you have the other ones. Now you should be good to go. Do you have any questions over the fluid worksheet at all? Do you have a chance to get through it and finish it all? Okay. Sounds good. That should be done by now if you haven't done it. Anyone who has not finished the fluid power lab, which, let's see, is this the right one? Source, PC output. Fluid power, yeah, it looks like this. And you have different activities in here where you're learning about how fluid power drives devices, and they have different questions and different little activities and little things that you have to do a little research for. It's a little bit of math, nothing too difficult, I don't think. Talk about pressure a little bit, how pressure is a force that is spread out over an area, and how you can change the pressure by changing the area. So you can increase pressure by making a smaller area, or decrease pressure by making a bigger area, and so on and so forth. But like I said, it's not terribly difficult. So go ahead and work through that. And if you have any questions, please contact me, but try to get that done and completed and in to me today. Because now you have two other things to get working on. Well, one other thing to get working on, which is the actual hydraulic arm project. And I sent you these other two worksheets, which I'm not going to necessarily have you do the worksheets this time. These are just to give you some ideas on how to create different hydraulic arms that would be useful for this project. And if I remember, let's see if I can remember correctly, I wanted your hydraulic arm to be able to reach from the floor to, did I say 12 inches high? I think. And I want it to be able to rotate 90 degrees, but probably 120 would be a little bit better, give you a little more versatility. And I want it to be able to pick something up as close as 6 inches from the base, or at the base and 6 inches from the base, or something like that. So six inches out, 12 inches up, 90 degrees around. It should be able to have that kind of movement at the very least. And as an engineer, you should always over-engineer it a little bit so it can do a little bit better than that, so that when it's crunch time and you have to test it and you have to use it, it has a little wiggle room. Besides that, the only question that was asked of me is, what are we going to use this for? Why do we need to pick up tennis balls? And we thought of a couple good reasons to pick up things like tennis balls. The Mars rover, for example, picks up rocks, and you might even have a machine that picks up tennis balls. Who knows? But I think that's the only other real question that was asked. Do you remember any of the questions that you asked? Nobody else has emailed me any questions. I also mentioned that I do not want you to copy any of the ideas or any of the models here, or any of the designs here. You can use elements from these designs, but you can pick and choose some things from these different designs, but I do not want you to copy one of these. And in fact, it would be quite difficult for you to do so, since I haven't given you the proper materials to do so. Most of these use dowels and the plastic beams, and I haven't given you enough of those to do that. So you have to kind of redesign or design with what you have and the parts that you have, and go from there. Now, if you do need more syringes, you're welcome to use other syringes that you might have, or other tubing that you might have. And if you don't have syringes and tubing, and you need some more, email me as soon as possible, or call me or whatever, so that I can get those out to you as quickly as possible. Another thing we mentioned is I don't care what kind of fluid you use. I would recommend a liquid. Air does not work so well because for air to work, you have to have very high pressures, and the tools that I've given you do not allow for high pressures. So I would recommend that you use a fluid of some kind. Great fluids include water, oil, rubbing alcohol is a decent fluid for this. But I would say probably water and oil are the best ones. So water is probably best if you ever have to clean anything up. Oil is really good for making it run smoothly, but either one will work well. So, what else can we talk about concerning this? Make sure that you are keeping a logbook. Once again, I'm getting into your logbooks here, and one thing to explain here a little bit. One of the reasons that I'm struggling to catch up with grading is because I did get just a little bit behind in grading in all of my classes. But particularly with the classes that are distance learning like this, and I have students all over the place watching these videos at different times, is that I get all the assignments at different times. And I finally do have the first exam all in. Well, I think I still have one more out there, actually. But I think that I've got enough in to grade the exam, because I like to grade them all at once so that I get kind of an even kind of grading, since it is a very subjective exam. There aren't exact right answers to every question. I like to compare answers and see how students are learning compared to other students. And so it's a bit of a grade. You could say it's a bit of a grade on a curve, because I do look at everybody's exams at once. And the same with the homework. The homework isn't about this answer is right, this answer is wrong. It's about what are students getting out of the course? What are they learning about how it is to be an engineer? So I try to wait till everything comes in, and slowly things are trickling in, but that's the other reason it takes long to grade. So what I've seen so far, it looks pretty good. Everybody's doing well on the things they turned in. There are a few things that haven't been turned in by some people, and if that has happened, I will contact you to tell you to get those things in. But if you don't hear anything from me, you're in good shape right now, and I will get those grades out to you. I know I promised him 2 weeks ago, but I'm still kind of working out the final details here. So anyway, do get your logbook worked on. I'm starting to look at logbooks, and one thing that I notice about logbooks is that there's either too much detail or too little detail, and you want to have a nice balance. You want to have just enough information that if somebody else looks at your logbook, they know what you've done and they can repeat it. They don't necessarily need to know every single little thing you did. They need to know the essentials, the important things, things that were difficult, steps in a process that were important, and pictures to illustrate those things that are important. I don't need 9 pictures of every time you put together something in the car or something. I don't need to see a picture. I don't need an explanation of how to wind up a rubber band unless it's really a tricky thing, you know. So, and also I don't want to just see, well, I made this car, here's a picture of it, and that's it. You know, I want to see the steps, any problems that you came across, and so that somebody else who comes and makes it doesn't have to recreate that process. They don't have to look at your picture and try to figure it out. You've got enough steps for them to get started and to get the basic idea and to work through any problems that you encounter. So make sure that you don't have too much information, you don't have too little information, but it is enough for somebody to recreate what you have done. It's a very delicate kind of balance, the logbook. And even professional engineers struggle with too much or too little, too much or too little. And it takes a while to really find that nice middle point, middle road. So, are there any other questions that you have before you get going and get back to your work on your design and your process? Uh-huh. Okay, so that is one of the engineering challenges for sure, for certain. Some of the syringes are better for that than others, you've probably noticed. Some of them are just kind of syringes from a doctor's office. Some of them have a little bit of framework on them that allow you to work with them. And so I would recommend, first of all, you make your design about, that covers where syringes are going to be and what you're going to need where, and worry about attaching them later, because if you only need to attach 3 syringes and you have 3 syringes that have the framework on them that make it easy to attach, then your life is a little bit better, right? Whereas if you have 5 syringes you need to attach and you don't have enough of the syringes that have the framework on them, then you're going to be struggling to figure out how to put those on. And I have given you some parts that will allow you to attach syringes. There are some plastic parts in there that are designed for that use, but I've deliberately not given you enough, because I want you to be creative with the materials that you have and try to figure out, well, I need this syringe to be attached here somehow. With the parts that I have, can I design something? Can I build something? Can I create something? And that will be part of your troubleshooting and design process, is how to figure that out, because that is a very important part of engineering. And that's kind of the point of this project. Every one of the projects I've given you so far has a little bit of a challenge where you're supposed to apply what we've been learning about recently in engineering here. And in this particular case, we've learned a lot about troubleshooting. We've learned a lot about working with the things that we have. Now I want you to use those tools, those skills, to figure out something that's a little more challenging, like how to attach a syringe using just what you've got, right? So it is a bit of a challenge, and that is part of the project. So as far as suggestions go, well, I might consider creating something, creating a device, creating a part, a frame with the parts that you have. You're welcome to use wood glue to make things out of wood, and that's a really good option. Just make sure that when you make something out of wood, that you wait for it to dry completely at least 1 day before you do anything with it. If you wait for it to dry completely 1 day, it will be stronger than you could ever need it to be, and you will have lots of success with it. Otherwise, you will have things breaking. Wood glue is very, very strong when you let it cure. It's actually stronger than the wood it glues together. So that's kind of what I can give you as far as. Does that answer your question? Okay. Yeah. Absolutely. Absolutely. You can use oil as your fluid, or you can oil them with just use like a baby oil, mineral oil, or whatever kind of oil. It really doesn't matter. Vegetable oil work fine. You can oil them before you put water in them, and that will work fine. And that certainly does help with all of the syringes. Yeah, the fact that they're difficult to plunge is just a result of them having to be very, very tight fitting. If they're not tight fitting, they don't seal up. If they don't seal up, they leak. If they leak, you lose power. So it's kind of hard. It's hard to get around that, but oil is a big way to do that. Any other questions? Okay, if anyone else has questions concerning this project, if you didn't get any of the emailed materials or whatever else, if you need more materials, please email me as soon as you can or contact me as soon as you can, and we will be done for today. Just get going on this project and have fun with it. And we'll see you later.